guys. So in class we've been looking at the oxidation of aldehydes and ketones, and we've been carrying out an experiment to oxidize different aldehydes and different ketones. Today we're going to be looking a bit closer at the products of that reaction. So if we look at the family of carboxylic acids, and we start with methanoic acid, the structure for methanoic acid, we've got one carbon, we've got our carboxyl group attached to that carbon, a C double bond OH, and we add a hydrogen so that carbon has 4 bonds. Our molecular formula here is CHCOOH, and our shortened structural formula will be the same, CH, one carbon, one hydrogen on the first carbon, and our functional group at the end, COOH. Ethanoic acid, we've got 2 carbons in the chain. The carboxyl group is always at the end of the chain because we are oxidizing an aldehyde, and aldehydes are at the functional group on aldehydes is at the end of the chain, so carboxylic acids are also at the end of the chain. And I'm going to fill in my end carbon with hydrogens here. So my molecular formula here, I've got, there's 2 ways you can write this, CH3COOH, and keeping the functional group together, or you can separate it into carbons, hydrogens and oxygens, so we can have C2H4O2. Either of those would be correct. It depends if you want to keep the functional group as one group in the molecular formula, or if you want to separate it into carbons, hydrogens and oxygens. Our shortened structural formula, the first carbon has 3 hydrogens and the next carbon has our functional group on. And propanoic acid is 3 carbons carboxyl group at the end of the chain, hydrogens surrounding the other carbons, and molecular formula here, again, two options. We could have C2H5COOH, or we could have C3H6O2. Shortened structural formula, CH3CH2COOH. So if you could pause the video just now and fill out the rest of the table for the carboxylic acids in your pupil booklets. What I want to go over quickly is an oxidation summary for all of the different oxidation reactions that we've learned about so far. So, for example, we have looked at, first of all, primary alcohols. And we know that when we oxidize a primary alcohol, we make an aldehyde. And aldehydes can also be oxidized further to make a carboxylic acid. If we go back the way then, we are reducing carboxylic acids to aldehydes and reducing aldehydes to primary alcohols. We've also looked at secondary alcohols. And they can be oxidized to ketones, but they are not oxidized any further than that. But ketones can be reduced to secondary alcohols. And then we have tertiary alcohols, which are not oxidized at all. So primary alcohols to aldehydes, carboxylic acids, and we can reduce back the way carboxylic acid to aldehyde to primary alcohol. Secondary alcohols are oxidized to ketones but are not oxidized any further and can be reduced back to secondary alcohols. Tertiary alcohols are not oxidized at all. We will be doing a bigger and more detailed version of this summary, but if you could copy this summary into the space in your pupil notes, and we'll do a separate one in class as well. Now, carboxylic acids are a very useful family of compounds. They undergo quite a few reactions. One of the ones we've already looked at is reduction of carboxylic acids, and we know that we can reduce carboxylic acids first to aldehydes and also to primary alcohols. So that is one of the reactions that carboxylic acids undergo. In National 5 chemistry, we also know that carboxylic acids undergo neutralization reactions. And last year we talked about 3 different neutralization reactions. Reacting acids or carboxylic acids, firstly with metal oxides, producing salt and water. Secondly with metal hydroxides, producing salt and water. And thirdly, with metal carbonates, producing salt, water, and carbon dioxide. So they can take part in these 3 different neutralization reactions as well. Now, what makes carboxylic acids different from normal acids is that they are particularly weak acids, which means they don't fully dissociate or break up into their ions in water. So we can see this where we are starting with here methanoic acid. And when methanoic acid is added to water, some of the methanoic acid splits up into 2 different ions. The CH3COO-, which is your negative ion or your anion, and H+, which is your positive ion. And remember, it is this H+, which makes acidic solutions either lower pHs or higher pHs. Carboxylic acids do not fully dissociate, which means not all of the molecules of methanoic acid will split up into a negative ion and a positive ion. So they're weak acids because they only produce a little bit of your H+ ion. When neutralized, the carboxylic acids produce salts which contain the carboxylate ion, which is your COO minus ion, and we'll talk about that a little bit later on. Another use of carboxylic acids particularly their salts, are used as preservatives in the food industry. So calcium propanoate and sodium benzoate are a few examples of preservatives that are used to prevent the spoiling of food, which is obviously a very important use in today's world for the salts of carboxylic acids.